In this presentation, I'm going to try and cover ASME Section 9, P numbers, F numbers, and A numbers. My name's Gary Pace. I'm a professional engineer in CWI. I'm out of Katy, Texas. You can see there's my contact information and my website, texasweldingengineering.com. Going to try and clear up maybe some questions about P numbers, F numbers, and A numbers, or maybe just help you understand them a little better if you're a newcomer to this and wondering what the heck do we got going on. So I'm going to try and help you navigate a couple of the nuances involved in P numbers, F numbers, and A numbers. Examples of essential variables. These are some examples of essential variables for gas metal arc welding and flux core arc welding, which under ASME Section 9, gas metal arc welding and flux core arc welding are the same process, considered the same process. Even though there's some differences under ASME Section 9, they call it the same. So you'd have shielding gas, mixture or percentage of the composition is one of the essential variables, post-weld heat treat transfer mode. And then we're going to talk about, the three we're going to talk about in this presentation are P number, F number, and A number. P number is your base material grouping. So it could be something like a carbon steel, a titanium alloy, copper, aluminum, nickel alloys, whatever. They're all broken down into a specific P number grouping. F number is the filler material grouping. So if you're using a nickel-based alloy, you could have an F22 or F42. Aluminum would be an F22. But not every material that has an F number has an A number. The examples that I just gave you of nickel and nickel alloys, aluminums, coppers, titaniums, they're non-ferrous metals, so they don't have an A number. To have an A number, you have to be a ferrous material. Austenitic stainless steel, a duplex stainless steel, a high alloy steel, a garden variety carbon steel. If you're a ferrous alloy, ferrous meaning the bulk of the material is made up of iron, you're going to have an A number on that filler material. So that's where A numbers come in. So if you're dealing with titanium, zirconium, or one of the other non-ferrous materials, you don't have an A number. F number, all filler materials have them, and then P numbers, all base materials have them, but an A number is just for ferrous weld materials. Here's a procedure qualification record. So here's where we've got our essential variables, our P number, F number, and A number listed on here. So in blue, in the little blue circle, we've got our P numbers. So we're welding a P number 8 to a P number 8 for this procedure qualification record. And the filler metal we're going to deposit in that weld is F5 type filler metal, and it's going to be an A number 8. The weld metal analysis, the chemical analysis on that is going to be an A number 8. If we were doing something that was aluminum or titanium or a non-ferrous metal, we wouldn't have an A number. We could leave that blank, put none or not applicable. So here's what a general run-of-the-mill PQR looks like. And there's the three variables that we're going to be talking about today. Okay, so we already looked at the PQR, and just as a general review, the PQR supports the WPS because the PQR is the documentation that records what essential variables we've done when we've made our weld test coupon. So then we write up our PQR, and that's the documentation that's going to support our WPS. So now we go to our WPS. And you can see that the three essential variables that we were talking about on our PQR, which is going to support our WPS, are also listed on this document. So you can see in blue we've got our P numbers. We're welding a P number 8 to a P number 8. And our F number is F number 5. and our A number is A number 8. Just as an example here of what a WPS can look like, you're not locked into this format, and here's a little tighter shot of the previous screen. You can see we've got a P number 8 welded to a P number 8, and then we've got our F numbers and our A number on here. So this is what's going to give direction to the welder when he's making a weld. So the actual filler material he's going to look at is going to be on a chart included with the WPS, but we're not going to cover that. We're just going to talk P numbers, F numbers, and A numbers here. So straight out of ASME Section 9, P numbers are assigned to base metals for the purpose of reducing the number of welding and brazing procedure qualifications required. P numbers are alphanumeric designations accordingly. Each P number shall be considered a separate P number, e.g., base metals assigned to P5A are considered separate P numbers from those assigned P5B, P5C. So what is this telling us? It's telling us that back in the day, ASME went through, the American Society of Mechanical Engineers went through all these base metals. And let's say for carbon steels, they looked at all these carbon steels, and yeah, they got a different recipe, a little more carbon, a little less nickel, a smidgen of chromium in there, or whatever alloying elements you're using. And they said, all right, all this stuff that's carbon steel is pretty much the same in regards to weld procedure qualification. So they said, all right, all this stuff, we're going to put it in P number 1. So if you qualify a weld procedure to weld P number 1 to P number 1 material, you get everything in that P number 1 group. Or if you qualified a weld procedure to weld P number 8, which is austenitic stainless steel like 304, 316, 309, to your garden variety carbon steel, which is P1, you could weld one example of P8 material to one example to P1 material, and you'd get all the combinations of P1 to P8. And this only works if there's no impact testing involved, as far as how I'm explaining what you get. If there's impact testing required, there's group numbers. And the group numbers break it down further in regards to a material's ability to withstand impact at various temperatures. So that kind of tightens things up a little bit. But without impact testing, if you qualify one P number, like let's go P number 43, which is a nickel alloy, to a P number 8, which is a stainless steel, austenitic stainless steel, you get all the P number 8s to all the P number 43s. No questions asked. Once again, unless there's impact testing involved. Here's from QW 420, base metal groupings. This is how ASME Section 9 breaks out the base metal groupings. You can see steel and steel alloys, pretty much anything that's an iron-based alloy. Your ferrous materials are P number 1 through P number 15F. Aluminum and aluminum base alloys are in the 20s. Copper alloys are in the 30s. Nickel and nickel alloys are in the 40s. Titanium, 50s, and zirconium's the 60s. So this gives you a pretty good idea of P1 through 15 is your ferrous alloys. Martensitic, austenitic stainless steels, duplexes, everything is lumped in there. Garden variety carbon steels. And then you've got your non-ferrous alloy systems are, the 20s, 30s, 40s, 50s, and 60s. So give you a general idea of what's what and how they went through and broke these out. If you go to the QB 422 non-ferrous and non-ferrous P numbers, this is where you're going to look for and to see if the material you're going to be welding has a P number. So you can see that on the far right, we've got our specification number. So this would be SA249, type 316. It's a 316 stainless steel. And then you can see over here where I've circled the P number on the top, That's the P number. So there's pages and pages and pages of this. I just picked this one at random because I kind of am familiar with 316 stainless steel, and it seemed like a relevant thing to talk about. But when we're talking about P numbers and how to find your P numbers, you look up on this left-hand side where your specification number is, and then you find your number and you go down and say, oh, that's a P8. If your number isn't on there, if you've got some kind of material that isn't listed on here and it doesn't have a P number, well, then that's an unlisted material, and that's a conversation for a later date. You might have some kind of, Lithuanian, stainless steel that's similar to, 316, but if it doesn't have, if it isn't certified as SA whatever, then you can't use it as that P number. Even though metallurgically it might be the same stuff, it's not as far as ASME is concerned. So anyways, this is how you look up a P number, and it's all in QWQB 422. Here's an example of using P numbers. If we qualified a weld using these P numbers on the PQR, P number 1 to P number 1, SA 53 to SA 36, and with no impact requirements, we're not doing the impact thing, and let's say we're using a E7018-1, which would be an F4A1, we can then weld any P number 1 material listed on table QW QB 422 to any other material listed on that table that has a P1. We get the whole deal. There's pages and pages and pages. So if we qualify P1 to P1 and there's no impacts, we get all of those P1 materials. We can mix and match to our heart's content. Once again, this is with no impacts required. If there's impacts, it's a game changer. But for just a garden variety welding procedure, we qualify our PQR, P1 to P1, we get them all. So you can see how useful this would be, and why ASME did this. It's to keep from having an infinite number of weld procedures required down to, maybe you can do it in a handful. Here's another example. If we qualified using P number 1, an SA53 to a P number 8, an SA249 type 316. So you're going 316 to any to a carbon steel P1, and we're going to use 309, which would be an F5A8. We can then weld any P number 1 material listed on the table to any P number 8 listed on the table. Once again, this is no impacts required. If you go through those tables, there's a zillion, and I say a zillion, but there's a huge number of P8 materials and a huge number of P1 materials. So if you can do P1 to P8, you've covered a lot of ground. So, and that, once again, that's why ASME Section 9 did this. They decided, okay, we're going to group base materials so that it's like, okay, this stuff is pretty much the same. There's some minor changes in the constituents, but for mechanical properties and mechanical properties in regards to welding, it's the same stuff. You weld one of these to one of these, you're good. So just something to keep in mind as you're qualifying weld procedures. And we'll talk about the F numbers and A numbers later on. Here we're going to look at our F numbers and A numbers. These two go hand in hand. F number is the filler metal product form, the filler metal type. And then the A number is the chemical composition. And this only counts for the chemical composition. We only worry about for ferrous materials. So nickels, aluminums, titaniums, all those copper alloys, whatever, they don't have an A number. If it's a ferrous filler material, an austenitic stainless steel duplex, ferritic stainless steel, garden variety carbon steel, high chromium alloy steel, whatever, it's going to have an F number and an A number. But it boils down to it being a ferrous material, so something to keep in mind as we go forward. Q430 F numbers. The following F number groupings of electrodes and welding rods in table QW432 is based essentially on their usability characteristics, which fundamentally determine the ability of welders to make satisfactory welds with a given filler metal. This grouping is made to reduce the number of welding procedure and performance qualifications where this can be logically done. The grouping does not imply that the base metals or filler metals within the group may be indiscriminately substituted for a metal that was used in the qualification test without consideration of the compatibility of the base and filler metals from the standpoint of metallurgical properties, post-weld heat treatment, design, and service requirements, as well as mechanical properties. So what is this telling us? This is right out of the code. So this is telling us that they group together like they did with the P numbers, where they group base metals together and said, okay, this kind of base material is close enough for our qualifications. You qualify one of these to one of these, it's good enough. It's close enough. You can't indiscriminately use them for each other, but they're good enough for qualification purposes. It shows that you have the ability to make a sound weld and deposit sound weld metal into that joint and get a satisfactory result out of it. Well, that's what they did with the F numbers. So, for, let's say, E6010 and E7010, they're both the same. They have the only difference is the tensile strength. There's a little more carbon in one than the other, right? And some other chemical constituents in there also. Or E7018 and E8018. Pretty much the same. They're going to flow the same. They're going to have a different chemical composition, but from a usability characteristic, it's going to be the same. So ASME Section 9 said, okay, these are all the same. So for E6010 and E7010, they're both going to be F3 materials. E7018 and E8018, they're both going to be F4 materials. So it was just a way to cut down on the amount of procedure qualifications and performance qualifications to keep you from having to qualify a welder for every time he qualified on a different filler metal. They grouped it and said, okay, if the welder can qualify with one of these filler metals, he gets all of them. They're all grouped together. It's going to save us a lot of time and money. It's close enough to be in the same thing. They have the same usability characteristics. We're going to go with it. So that's why they did it. That's why they grouped it, made things into F numbers. So here's the chart from ASME Section 9. You can see we've got F numbers. The red circle's the F number. The green circle's the ASME specification. And then the blue circle is the AWS classification. So you can see the top, we've got F1, 2, 3, 4. Can't read them very well. I did a blow up on a later one, but kind of give you an idea of what the chart looks like. So you're gonna find out what your AWS classification is. Okay, I used E70 E7020, which would be the very top one up there. So that would be an F number 1. So, you just go down here and figure out, okay, what was the filler metal I used? Is it listed on here? Okay, it's listed here. And then you go to the other side and say, yep, okay, there's my F number. That's my F number that I'm going to put on my PQR and my WPS. Here's some examples of some F numbers. I blew it up a little more, threw in a picture of some shielded metal arc welding filler material, which is probably, F1, 2, 3, 4, or 5. I don't know what these are, but I've got a picture of them. So you can see that, like the top there, we've got, F number 4, EXX15. So if we qualify something with a 70-15, then we would also get 80-15, 90-15, whatever. It all falls into the F4 category. So if we qualify a weld procedure with an F4 filler material and the A number matches up for ferrous weld metals, then we can use anything with that F number and A number. The reason that they break this out is there's a lot of different chemical compositions on the weld metal that's deposited. You might have an F number 4 and an A number 6. I'm using some crazy examples. Or an F1 or an F4 and an A1. That's a carbon steel. Whereas you could have an F4 and an A, 3, which would have some chrome content to it. You can't use those interchangeably. So you can see how the chart looks and what we're looking at when we're trying to qualify a weld procedure. Here's an example of some F number 6s. Once again, threw in some pictures to give you an idea of what we got going on. So you can see the picture on the right, the copper colored picture. That's an F6. That's an ER70S6. It's an F6 material. So we'd have to check out the A number on it because it's a carbon steel. It's a ferrous material. And then you can see where I've got a picture of some flux cord material. Also an F6 material. So F6s are generally ferrous materials in wire form. They're not covered electrodes like the F1 through F5s are. So something to think about, but gives you an example of what we're talking about when we're talking about F numbers. Also, you can see for F6, all classifications, like on F1, 2, 3, 4, they had it broken out into E7, EXX18 or EXX whatever. For some of this F6 material, it's all the classifications are considered F6, but not to be used indiscriminately or interchangeably. They're just qualified that way for usability characteristics. Here's some examples of some F numbers in the nickel alloys. I chopped it out of the same chart. And so you can see we've got, a bunch of different nickel alloys. So not all nickel alloys are the same. You've got F41, 42, 43, 44. These are not going to have A numbers. These are non-ferrous materials, and they're not going to have an A number. All our previous stuff was going to have an A number. These are not. Aluminums, nickels, coppers, titanium, zirconium alloys, they're not going to have an A number. They're non-ferrous materials. A numbers only apply to ferrous materials. Austenitic, ferritic, garden variety carbon steels, your 2 1/4 chromes, whatever. Anything that's a ferrous material, a steel with some that's been alloyed and is still a ferrous alloy, it's going to have an A number in addition to having an F number. ASME Section IX A numbers. ASME Section IX A number is the chemical composition of the filler material in the as-welded condition. The A number is an essential variable in most welding processes in ASME Code Section IX. Table QW 442 in ASME Code Section 9 gives the list of A numbers. Note the A numbers do not refer to the filler wire or electrode chemical composition. It refers to the deposited weld metal chemical composition. The filler metal and deposited weld metal have different chemical compositions. So this is the chemical composition, not of the wire on the spool. It's the composition of the wire or the filler material in the welded condition once you put it into the joint. And once again, A numbers are for ferrous materials only. This does not work for titanium, nickel alloys, coppers, aluminums, or zirconiums. Ferrous materials only. Only ferrous materials have A numbers. Here's QW440, weld metal chemical composition. This classification is for ferrous weld metal analysis for procedure qualification only. This doesn't count for nickel alloys, aluminums, coppers, or titanium or zirconium. Ferrous alloys. So you can see our A number. So your garden variety mild steel is going to have an A number 1. As we throw some more alloying elements into it, chrome. Your chrome mollies are going to be A number 3, 4, 5. Martensitic stainless steels A6. Chrome, ferritic stainless steels are 7. Your austenitic stainless steels are going to be A number 8. You can see, so it breaks it out. But this is just strictly for ferrous weld metals. This is not for coppers or anything. So if you're looking for an A number for a copper or a nickel alloy, you're going to be in trouble. There isn't one. But stainless steels, carbon steels, chrome moly steels, they all have an A number. And it's an essential variable that you need to address on the PQR and the WPS. Okay, give you a summary. Trying not to make this presentation too long, but trying to put as much in here as possible. So remember, we touched base on the P numbers, and our P numbers are our metal groupings. So things like nickel alloys, they went through and grouped those into P41, 42, 43, and said if you get a weld procedure qualification with one of these to another one of these, okay, you get everything in that P number group. If I qualify a weld procedure with a P number 1 material to another material that's a P number 8, I get everything in P1 to everything in P8. ASME did this to keep the number of weld procedure qualifications to a level of sanity so that you didn't have just a huge number of them. So then we talked about filler metal F numbers. These are the usability characteristics. So if we had something like an F6, which is a spooled wire, it can be cut length too, but let's say we have F6 materials. Those are bare electrodes. You could have an F6 that is stainless steel, and you could have an F6 that is carbon steel. And once again, we have A numbers for ferrous materials like that. If we've got a situation like that where we've got the filler metals are both F6s, it would be, your carbon steel would be an F6A1 and your stainless steel would be an F6A8. So, but I hope when I went through it, you figured out how to look them up or find them, the F numbers and the A numbers, and realize that A numbers are for ferrous materials only, and the F numbers are, the weld metal usability characteristics. So hopefully this gives you a little insight. I tried not to get too crazy with it and get too long-winded, but anyways, hopefully this helps you gives a little insight into P numbers, F numbers, and A numbers. If you got any questions, here's my contact info. Once again, Gary Pace. I'm a professional engineer in a CWI. I'm out of Katy, Texas. Here's my contact information and my website, texasweldingengineering.com. You got questions about P numbers, A numbers, F numbers, or PQRs, WPSs, or just welding questions in general, don't be afraid to bounce me a question and ask. Anyways, take care. Have a good day.